Welcome to day 1 of simplifying square roots and cube roots. You have done square roots in the past, so part of this will be a review. When we're looking at the square root, anything underneath the square root, inside of it, we call the radicand. The square root itself, we call that symbol a radical. You'll hear me use that word again. And any number up in the top corner is called our index. For square roots, there's no number there, but we can think of it as a number 2, the same way we think that x squared has an exponent of 2. Usually you will not see a number there for square roots. What I would like you to do now in your calculator is do the square root of these 4 examples. To do this in your calculator, you're going to press second, x squared, which is the 5th button up on the left side, and then type in the number and hit enter. Take a minute to do these 4 problems. If you get an error in your calculator, it's okay. Please check your answers with the ones on the screen. You will notice that when you did the square root of -4, you got an error. That will always happen. You cannot take the square root of a negative number. If you ever get a negative inside of the square root, there either is no answer or we did something wrong. And we'll look at that more in depth in the next unit. A perfect square happens when you take the square root and you get a whole number, like those 4 examples above. Perfect squares are going to be needed in order to simplify the problems that we're doing today. If you do not know how to make a list of perfect squares, pay attention now. We usually start with 12 times 12. That'll usually be okay for us, and we work down from there. So in my calculator, I did 12 times 12, and I got 144. I then went down to 11 times 11, and got 121. 10 times 10, got 100. I'm going to keep going all the way down to 2 times 2. This is my list of perfect squares. This list can be built higher by doing 13 times 13, 14 times 14, and so on. You do need to know how to make this list. If you memorize it, it just makes your life easier, but it is not required. We're now going to move on to simplifying numbers that are not perfect squares. Our first step for this is we're always going to check to make sure the number is not a perfect square. If it is perfect, it's going to make our life easy, like the first 4 examples on the first page. So I'm going to go to my calculator, and I'm going to type in the square root of 50 and figure out what it equals. When I type this in my calculator, I get 7.07. This confirms that it's not a perfect square. My second step is I'm going to list out all my perfect squares. So I have the same list that we made on the front. If you do not know how to make this list, re-watch that first part again. I'm now going to ask myself, where does this number 50 fit into my list? And I notice that 50 fits right in between 64 and 49. Next, I'm going to divide, starting with the next number, so the number right below it. I'm going to keep dividing until I get a whole number. So in my calculator, I'm doing 50 divided by 49. And I see I get a decimal. So I'm going to move on. I'm going to do 50 divided by 36. I get another decimal. Keep moving. I'm going to do 50 divided by 25. I see that this equals 2. So I have divided down my list until I got a whole number. Step 5 means I'm going to rewrite the square root of 50 using those two numbers. I'm going to take the square root of 50 and I'm going to break it into 25 times 2. 50 was in a square root, so I'm going to put each of these numbers in a square root. One of these numbers should be able to simplify because it was a perfect square. The square root of 25 is 5. So I'm going to simplify this to 5 times radical 2. Or 5 times the square root of 2. This is my answer. But we want to make sure we did our problem right. So in order to check this, I'm going to type in my calculator 5 times radical 2 and see what decimal that gives me. When I typed it in, I got 7.07. When I first started this problem, I checked to see if 50 was a perfect square. It wasn't. It gave me the decimal 7.07, which is the same decimal I get now. Therefore, I know I did my problem correctly. When you do a simplifying of a square root, you're going to check first to see if it's a perfect square. If not, write down that decimal so you can come back to it later. Next, list out your perfect squares. You're going to find where your number fits in to the list, the same way we found out where 50 fit between 49 and 64. You're going to start dividing at the next number, so 49 would be the next number. You're going to divide until you get a whole number, or no decimal. You're going to rewrite it as a product or multiplication of those two numbers that you had circled, the perfect square and the answer to the division. The perfect square you're going to simplify. The other one will stay the same. Don't forget to check. Let's try another one together. I have the square root of 147. First thing I need to do is to check if it's a perfect square. So let's go to our calculator and check if it's a perfect square. In my calculator, I get 12.12. Not a perfect square. So now I need to figure out where it fits in my list. I already have my list started, but my list needs to go higher than the number I'm dealing with. So right now I have 10 times 10. I need to add 11 times 11. Still not high enough. 12 times 12. Still not high enough. So we'll do 13 times 13. Now I can actually see where my number fits. So 147 fits in between these two. So I'm going to start dividing at 144. And I'm going to divide until I get a whole number. Sometimes you can divide only a couple numbers. Sometimes you have to go very far down the list. So take a minute to divide until you get a whole number. When I divided 147 divided by 49, I got 3. So these are the numbers I'm going to split 147 into. So 147 is the same thing as 49 times 3. 147 was in the square root, so both of these have to be in the square root. One of these should simplify. Do you know which one is a perfect square? 49 is your perfect square. If you don't remember what the square root of 49 is, put it in your calculator. Square root of 49 simplifies to 7. Bring down times the square root of 3. And we have our answer. Let's check to make sure 7 times the square root of 3 is the same decimal as we got at the beginning. In my calculator, I'm going to type in 7 times the square root of 3. I get 12.12, which is the same decimal I got in the beginning. Therefore, I know I did my problem correctly. Try the rest of the problems on this page. If you get stuck, go back and re-watch the first 2 examples. Follow your steps in order. If you need additional time, please pause the video while you finish the problems. Once again, if you need more time to work on these problems, please pause. The answers will appear on the screen. Please check your answers if you are done. Your final answers are on the screen, and they are circled for those last 3 problems. If you got it wrong, did you check your answer? If you did check, you should have noticed that your decimals were not the same. Next, we're going to move on to cube roots. These are going to be very similar to square roots. Next, we're going to look at simplifying cube roots. These are new. You'll notice that the symbol for a cube root has a small number 3 as the index. Everything else is the same. Whenever you're dealing with cube roots, do not forget the 3. If you forget the 3, your problem is wrong. You can simplify perfect cubes in your calculator, just like you simplified squares. On your calculator, find the button that says Math. Math is right below the alpha button. In Math, the 4th one down, you'll see the picture of the cube root. Select that. Then type in your number and hit Enter. You need to remember where this button is. Math, 4th button down, enter your number, and hit Enter to find the answer. Please calculate the 4 cube roots listed in the top right corner. If you need more time to calculate these in your calculator, please pause the video. You will notice that the cube root of 8 is 2. The cube root of 216 is 6. The negative cube root of 27 is negative 3. You might have found it strange that you can take a cube root of a negative number. The cube root of negative 64 is negative 4. What this means is for the cube root of 8, that means that 2 times 2 times 2 equals 8. That 3 from the cube root is the same thing as the 3 of the exponent we've sometimes seen. Cube roots is the inverse or the opposite of the exponent of cubing something. Let's look at what our perfect cubes are. This is another list you're going to have to be able to create, but do not feel like you have to memorize it. It will be helpful if you at least recognize which numbers are your cube roots that are perfect cubes. For this list, because the numbers are larger, I usually start with 11 cubed, or 11 times 11 times 11. In your calculator, that gives you 1,331. I build my list down from here. So I would do 10 times 10 times 10 to get 1,000. I once again build my list all the way down to 2 times 2 times 2, which, as we saw above, was equal to 8. If you want to add in 1 times 1 times 1, you can, but it's always just going to be 1. Whether it's square root or cube root, it's still going to be the same number. When we are simplifying cube roots, we're going to use our cube root list. So anytime you see that small number 3, you should be writing down this list. Anytime that number 3 is missing, you should be using the square root list that we used on the previous page. So let's go through the steps again for simplifying cube roots. They're going to be the same as when we did square roots. My first example is going to be the cube root of 54. Notice the small 3 at the top of the radical symbol. My first step is to check if it's a perfect cube. So I'm going to go to my calculator, hit Math, select the fourth option, type in 54, and hit Enter, because I will need this decimal later. I get the decimal of 3.78. I did round here. So I checked to see if it was a perfect cube. I got a decimal, so it's not. So now I need to follow these steps. I need to list out my perfect cubes. I already have them printed for you. I'm going to ask myself again, where does 54 fit in my list? You'll notice that this time it fits very close to the bottom, right between 64 and 27. So I'm going to start dividing at 27. In my calculator, I type in 54 divided by 27. I notice that this time it works out very nicely to be the first option. When I divide by 27, I get 2. So I found out where my number fit in, and I divided until I got my whole number. My next step is the same as when I did square roots. I'm going to take my cube root of 54, and I'm going to separate it into 27 and 2. Because 54 had a cube root symbol on it, I need to put both 27 and 2 in cube roots. Don't forget the 3. If you forget that 3, your answer is wrong. I know 27 is a perfect cube because it came from my list, so I'm going to simplify it. If you don't remember what the cube root of 27 is, you can do it in your calculator. Math, select the fourth option, and type in 27. When you do that, you get 3. Cube root of 2 is not on my list, so it's going to stay as the cube root of 2. This is my answer. I'm going to check to make sure I did it correctly again. So in my calculator, I'm going to type in 3 times the cube root, so math, fourth answer, the number 2, and hit enter. When I check this, I see that 3 times the cube root of 2 equals 3.78. This needs to be the same decimal I got up top. And it is. Therefore, I did my problem correctly. My first step, I checked to see if it was a perfect cube. In my calculator, math, fourth option. I got a decimal, so I moved on. I listed out all my perfect cubes again. Make sure you use your cubes, not squares, when you see that little 3 there. I found where 54 fit in on my list, and I started to divide. When I rewrote it as 27 times 2. Make sure you put both 27 and 2 in the cube root symbols. My next step was to simplify my cube root, so I simplified the cube root of 27 into being 3. Always remember to check your answer. I checked, it got the same decimal, so I know I did my problem correctly. We're going to do one more together, then you'll have 3 to do on your own as well. If at the end of the second problem you still don't understand how to do this, please go back and re-watch. My next number is 640. I'm going to check to see if this is a perfect cube. So in my calculator, math, fourth option, 640. And I'm going to see what I get. I got a decimal, and that decimal was 8.62. Once again, I rounded. Because it's not a perfect cube, I need to simplify using my list. My list is already written out for you. I'm going to see where 640 fits in. It fits right between 729 and 512. So I'm going to start dividing at 512. And I'm going to keep dividing until I get a whole number. You might notice on this one we have to do more dividing than we did on the previous one. I got all the way down to 64 before I got a whole number. 640 divided by 64 is 10. So I'm going to use these two when I rewrite the problem above. I started with the cube root of 640, and I'm going to split it into 64 times 10. Make sure you put both of these numbers back inside of the cube root. One of these will simplify. Right now is a great time to notice that 64 is both a perfect square and a perfect cube. Be careful not to get these confused. The square root of 64 is equal to 8 because 8 times 8 equals 64. But the cube root of 64 is equal to 4 because 4 times 4 times 4 equals 64. This is the only number that appears on both lists. Be careful when you're doing square roots and cube roots that you pay attention to the 3 or the 3 not being there so you don't make a small mistake. Okay, back to my problem. The cube root of 64 we just discovered was 4. Cube root of 10 is not on my list, so I know that just stays as the cube root of 10. This is my final answer. I'm still going to check to make sure I did it correctly though. So I'm going to type this in my calculator, and I'm going to see what this decimal is. When I typed it in, I got 8.62. Was that the same decimal I had at the beginning? Sure was. Therefore, I did my problem correctly. What I would like you to do is try the next 3 problems. I have listed the perfect cubes for example 3. You're going to have to write them for examples 4 and 5. On a test, on a quiz, on an SOL, you will not be given any of these lists, so you need to be able to make them on your own. For cubes, multiply a number by itself 3 times. For squares, multiply it by itself twice. Take a few minutes to move on to the next 3 problems. If you need additional time, please pause the video while you work. Once again, if you need more time to work, please pause the video now, as your answers will appear on the screen for you to check them in a second. If you did not get a question right, please go back and double check the math. Make sure you use the correct list of perfect cubes. Make sure you divided correctly. Here are your answers to these 3 problems. Did you get them right? Make sure you always check your answer to make sure it is correct. Make sure you have your small 3 on your cube root symbol for each of your answers. If you forget the 3, your answer would be wrong, so be very careful with that portion. If any of these are incorrect and you do not understand why, please rewatch the video and try to find the small error. The last thing we're going to do for this portion is we're going to compare the 2 methods we just did. Simplifying square roots and cube roots is the same. You list out your perfect squares for square roots and your perfect cubes for cube roots. You then divide the same way. Once you have your whole number, you split it into 2 pieces and you simplify the part that came from your list. Make sure you know that for square roots, it's second and then the x squared button on the left side. For cube roots, it's math and the 4th option down. And this ends today's lesson. For the next lesson, you are looking for simplifying square roots and cube roots with variables. This will be day 2. Thank you.